Hey everybody, welcome back for another super exciting, video notes on YouTube here. Hope you're not getting too sick of the sound of my voice yet. I know I am. Anyhow, we're gonna be starting our quadratics. I know we technically started the unit with the last lesson, but we didn't see too much quadratic, or in the way of quadratics in the last set of notes. The complex numbers, you will see how they fit in pretty shortly here, but this is a unit about quadratics, so we're gonna today look at 4 ways to solve quadratic equations. Now that may seem like a lot, but technically 2 of these ways we know. Now remember what it means for a polynomial equation to be considered quadratic. What does it mean for our equation to be quadratic? Okay, quadratic means that the equation has a degree of 2, right? That means you're looking for an x squared to be the largest exponent that you see in that equation. And why is that important? Why is the degree of the equation important? Why is it important? Because it shows the number of possible solutions. Right? If we're solving a linear equation, degree of 1, we're looking for 1 possible solution. If it's a quadratic, degree of 2, 2 possible solutions. Degree of 3, cubic would be 3 possible solutions, and so on. Now, since our focus is on quadratics, I want to talk for a minute about what those 2 solutions could look like, okay? So, for example, these 4 equations, I would argue that the first one here, this x squared equals 4, I shouldn't have to teach you anything. You should be able to tell me the solutions here. 2 solutions, right? What number, this is asking, what number can we square to get 4? Okay, what number can we square to get 4? Well, 2 is going to be a possibility, right? 2 squared is going to be 4, but also a negative 2 squared is going to be 4, right? Both positive and negative 2 squared make 4. So we could say plus or minus 2. Now what about 5? What number can we square to make 5? Definitely not an exact number, right? Maybe some of you are waiting for me to do this on the first one, but technically, if we wanted to solve this equation, if we had like an x plus 1 equals 7, we know to subtract 1 because that's the opposite of plus 1. Or if I had like a 2x equals 6 here, I know to divide 2 because that's the opposite of times 2, right? Well, if I wanted to solve this equation, and I'm trying to get x by itself, and it's being squared, right? What's the opposite of squaring something? It's taking the square root. So if I took the square root of this side, and I took the square root of this side, the square and the square root definitely cancel to give me x, but on the other side, the square root of 4 would only be 2. Now, that's still true that the square root of 4 is 2, but we're not really looking for the square root of 4 here. What we're looking for is what number squared makes 4, and so when we take the square root in the solving process, we have to put the plus or minus in there, because both the positive and negative squared are going to produce that result. Okay, now I've made this look really terribly ugly. So technically, we could have just said, what's the square root of both sides? So then x has to be not just 4, but plus or minus, or not just 2, but plus or minus 2. Okay, so we could do the same thing here. Since we don't know an exact number to square to make 5, I could solve by taking the square root of both sides. So the square and square root would cancel to leave me x, and I know it's going to be a positive and negative result. Now, since the square root of 5 isn't exact, then our solutions would be a positive square root of 5 and a negative square root of 5. Okay, so it's possible, in the first scenario here, we get these 2 nice rational solutions. In the second example, we still have, these are real solutions, real number solutions, okay? They're rational here, they're just irrational in the second set, but we've got 2 cases where we have real solutions. 2 real solutions, in fact. Now, in this next one, if we took the square root of both sides here, we're going to get x equal to, is there a sign attached to 0? I know the square root of 0 is 0. Is there a difference between positive and negative 0? No. So even though I could stick a plus or minus in there, it wouldn't separate that to 2 numbers. So there will be cases where you're going to get just 1 solution. Okay? Now in this last one, it's really tricky. Like, what do we square to get a negative 4? It's hard to think of, but again, if we go to, let's take the square root of both sides. Well, the square root of x squared is going to be x, and I know I have to put it in a plus or minus here. What are we going to say for the square root of negative 4? Now, there is no real number solution here, but we can simplify the square root of negative 4, right? If the square root of positive 4 is 2, the square root of negative 4 is 2i. And so what we have is two imaginary solutions. Okay, and the breakdown of what happens in these four problems is basically what happens anytime you solve a quadratic. Majority of the time you're looking for two solutions. It's possible that you get what we see here, two real solutions that are also rational. Okay, here you get two real solutions again, but they're irrational. Here you get just one solution, and 0 happens to be a real and rational number. One real and rational solution. And then if you end up with a negative under that square root, then you're going to get two, these are imaginary, but they could be complex if we stuck the real in there with it. So we could say two complex or imaginary solutions. Okay, one of those four things is going to occur every time you solve a quadratic. So it's possible that you have two, what do I have here? Two real solutions. Okay, it's possible that you have one real, why did I put that in pink? Let me do that again. It's possible that you have two real solutions, and they could be two rational, two irrational. It's possible that you have one real solution, or it's possible that you have two complex or imaginary solutions. Okay, so one of those options every single time. Now, what we did to solve here is, I can't remember when we looked at it last, but it's somewhere along the line we've seen using the square root to get rid of the square, right? And that's a process we can apply whether the equation looks simple like these four or there's a little more to it. The goal would be to make these look like the others. If we could get this x squared all by itself, then we can square root to get rid of that square. Okay, and we've done this before, like if it was to square root of x minus 1 equal to 17, I would add the 1 over, right? Divide the 2 over, and then to get rid of the square root, we'd square. This is almost the same thing. We're going to add the 1, we're going to divide the 2. It's just we're going to be getting rid of a square instead of getting rid of a square root. Okay? So what we want is for these equations to look like the ones we just saw, where the x squared is all by itself. So we're going to try to get the squared term alone. And then we're going to get rid of the square by taking the square. Why did I? It's not going to fit. By taking the square root, let's put that, of both sides of the equation. And then you have to remember that when you're taking, let's say, a square root of 4, a square root of 4 is just 2, but when you're solving x squared equals 4 and taking the square root, you're not really looking for the square root of 4, you're looking for what number squared makes 4, and so both the positive and negative make that true. Every time we take the square root in the solving process, we're going to have to put a plus or minus in front of the number that we took the square root of, okay? So we have to remember the plus or minus. And remember, we're looking for two possible solutions, right? So we can't forget that plus or minus. Now, sometimes you're going to be done at that step. Sometimes it'll still be necessary to get x by itself. And I'll show you some of those in a minute, okay? So here, getting the squared term by itself. Let's add 1 to both sides. So we're going to have 2x squared equal to 18. Let's divide both sides by 2. Cancels that out, and so now we have x squared equal to 9, and now to get rid of the square, we're taking the square root. So we have x all by itself equal to, gotta put in the plus or minus, because what number squared makes 9? Both positive 3 and negative 3. Okay, so plus or minus 3 are our two real and rational solutions. Okay, two real, rational solutions. And you don't have to write that every time, I'm just trying to stress that point, okay, because that's going to come back. All right, here, I want to get the x squared by itself. First step, let's get rid of this plus 2. If we subtract it over, then we still have an x squared divided by 5 equal to negative 5. So how do we get rid of divide 5? Well, we multiply by 5. So multiply, I don't like the dot here. Let's multiply this side by 5, let's multiply this side by 5. These cancel. And so now x squared is equal to a negative 25. Now we're going to get rid of the square by taking the square root. So square and the square root cancel, x is all by itself. Gotta put in a plus or minus, and the square root of negative 25. Well, the square root of positive 25 is 5, and since it's negative, it's imaginary. So plus or minus 5i. So these, I don't want the pink there yet. So these, again, two solutions. But this time we have imaginary solutions. So this is two imaginary solutions. Okay? Now, if you notice number 3 looks a little different. We've got the parentheses in the problem. So when we're trying to get our squared term by itself, this whole x minus 5 is our squared term. So the goal would be to get this x minus 5 squared, right, that piece by itself. So we're going to start this one by dividing both sides by 3. That makes that cancel. And now we have this x minus 5 squared equal to negative 9. Now I can't move the 5 yet, it's stuck in the parentheses, but I can get rid of the parentheses if I get rid of the square, and I know how to do that. So at this step, I can square root both sides. So that's going to leave me an x minus 5, and over here, gotta put in my plus or minus, and then for the square root of negative 9, we're looking at a 3i. Now this is one of the cases, as I mentioned in the steps here, right? If necessary, you still need to solve for x, you might still have to get x by itself. That happens here. So we took the square root of both sides, but we're not done. X isn't by itself. There's still a minus 5 there. So we're going to take one more step. We're going to add 5 to both sides. That cancels. And x is going to equal. Now, can I really add 5 to 3i or negative 3i? Well, we looked at yesterday, not like terms. I can't put reals and imaginaries. I can't actually combine them. So I'm going to leave the 5 separate from the plus or minus 3i. And now we have our complex solutions. So this would be two solutions. 5 plus 3i is a solution, and 5 minus 3i is a solution. And it's going to be two complex solutions. Okay? Now remember, the standard form for the complex number says to put the real part first and then the imaginaries. Although if you had plus or minus 3i and then plus 5, that would be okay. This is just standard form is preferred here. Okay? So let's try to use that when we can. Alright, here's another similar to what we just did. The squared term is a binomial, but that's okay. We want to get it by itself. So this one starts with adding 2 to both sides. So we have x plus 1 squared equal to 24. Now I'm going to get rid of the square by taking the square root. And that leaves me x plus 1 equal to, gotta put in a plus or a minus. Now there's no square root of 24. So what do we do with something like this? Well, we know how to simplify radicals. If I was to break down 24, it's 2 times 12. 12 is 2 times 6. And that means a 2 can come out of the radical, and a 2 and a 3 are going to stay in. So this becomes a 2 radical 6. So I couldn't take radical 24, but I could simplify. Radical 24 becomes 2 radical 6. Right, now I still got to solve for x here. Since there's a plus 1, I got to subtract that over. So x is going to equal, this is just like the last one. I can't combine 1 with a 2 radical 6. Right, the radicals can only be combined with other radicals, so I can only combine radical 6's with other radical 6's. So this negative 1 and this plus or minus 2 radical 6, those have to stay separate. Now these are two ugly solutions, but they're real solutions, right? There's no imaginary in there. So this would be two real solutions, but these ones are irrational. What did I put over here? Two real and irrational solutions. Don't need to write all that out. Let's stick with soul. Okay, so two real solutions are just ugly. They're irrational, those non-repeating, non-terminating decimals. All right, I think I have one for you to try. If you want to pause, give it a shot. This one is a little trickier because there's an extra piece inside the parentheses. So if you don't want to try, I don't blame you, but let's see. We're going to subtract the 1 over. So let me do that again. Subtract the 1 from both sides, and that leaves us 2x minus 3 squared equals 16. We know we're going to get rid of the square by taking the square root. That leaves us a 2x minus 3 equal to Gotta put in the plus or minus. The square root of 16 makes 4. And then here's where it starts to get tricky, okay? I want to add 3 to both sides, but I'm adding 3 to 2 different numbers, okay? So I see a lot of mistakes here. We'll see a lot of people want to make this plus or minus, let's say 7, but it's not adding 3 to 4, it's adding 3 to 4 and negative 4. So what you want to do is make sure you see this as 2 separate numbers, okay? This is positive 4 and negative 4, right? If I add 3 to positive 4, I get 7. If I add 3 to negative 4, I get negative 1. So I'm looking at 2x now equaling 2 different things. It's going to equal 7, and it's going to equal negative 1. And I'm just going to put a comma in there so I don't have to solve 2 separate equations, okay? My last step here, still have to divide by 2. I just got to make sure I divide both of these by 2. So my x is going to be equal to 2 things. There's my glue. X is going to be equal to 7 halves and negative 1 half. Okay, so x is equal to 7 halves and x is equal to negative 1 half. And if you wanted to separate them with commas like I did here, that's totally fine. I'll leave it that way. Just make sure you're not confusing that with a coordinate, right? That isn't a point on a graph. That's 2 separate solutions for x. And at any point, if you wanted to check any of these answers, I didn't mention this before, but you could absolutely plug them back in and make sure they work. And your calculator would be happy to do that for you. When I say calculator, I mean Desmos, right? So 7 halves, for example, just so you can see. In the parentheses, we have 2 times, I'm going to put in my 7 halves. Close that, and then if I subtract 3, and close the parenthesis, and square, and then add 1, my result should be a 17, and it is, right? And then if you wanted to check the negative 1 half, let's make that a negative 1 there, and that also gives me the result of 17. So at any point if you want to check your work, you could plug these things in, and that's really helpful if you're taking a multiple choice, let's say quiz, right? If you're not sure how to get the answers, use the multiple choice, plug in, make sure you got the right thing, okay? So we call this solving process solving using the square root method. I think the name makes sense because you're using the square root to get rid of the square. But that isn't a process we can use every time. In fact, it's not the first process that we looked at in this class. When we solved quadratic equations before, we had solved by factoring. Let me just show you on my scratch paper here. If I was solving like x squared plus 3x plus 2 equal to 0, would I even be able to use a square root to solve here? Well, if I got the squared term by itself, let's say I subtracted 3x over, subtracted the 2 over, and then I went to square root, what is the square root of negative 3x minus 2 going to look like? Well, I can't solve for x and then have an x on the other side of the equation. That's no good, right? So the square root method works in certain situations. It doesn't work here because of this term, right? If that wasn't there, this wouldn't be an issue. So if we have a squared term, and then we have some constant here, then we're going to be able to move that constant over and go ahead and take the square root to solve. But if we have a squared term and we have an x to the first term, then we want to try to solve by factoring, right? Remember the factoring process? Here, factors of 2 that make 3 are 2 and 1. And then what makes this factor equal 0 is one of our solutions, and what makes this factor equal 0 is another solution. So solving by factoring when this middle term is there, okay? So the square root method is nice, but only possible when the x to the first term is missing. Okay, so if you look at each of these problems, we have a squared term, and this is a constant, 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 no issues. We have a squared term, and then a constant, constant, constant. Okay, something squared, constant, constant. It's like no big deal here. But as soon as you introduce a squared term and an x to the first term, you can no longer use your square root method. So you want to try to solve by factoring. So we want our equation to be in standard form. That means we want the squared term, We want the x to the first term. We want the constant all equal to 0. So in order and equal to 0. And then we factor. And then we know the solutions are the values of x that make each of the factors. Make each factor equal 0. So here, what are the factors of 12 that make 13? Well, 12 and 1, and dividing by the one that's in front here is not going to change those. So if this factored into an x plus 12 and an x plus 1, then here we get a solution of negative 12, and here we get a solution of negative 1. Okay, here, got to get it in order and equal to 0. So we subtract the 4 over first. We multiply, let's see, 5 and negative 4 to make negative 20, and factors of negative 20 to make negative 8 would be negative 10 and 2. Now when our leading coefficient is not 1, we have to make sure we divide by that leading coefficient, and then reduce. This is going to reduce to a minus 2, which means this is going to factor into an x minus 2, and this is going to be a 5x plus 2. And now it's factored, so then our solutions are going to be positive 2 will make a 0 there, and then negative 2/5 will make a 0 there. And then remember, if you wanted a shortcut, if you remember the shortcuts, the opposites of the reduced fractions here are the solutions here. Okay? Here, again, we want a 0, so we're going to start by subtracting this x over and just make sure it goes to its like term. So we're looking at 15x squared minus 4x minus 3 equal to 0. So 15 times negative 3 is negative 45. To get a negative 4 in the middle, we can use a negative 9, a positive 5. Both of those have to be divided by 15. This is going to reduce to negative 3/5. This is going to reduce to 1/3. So this is going to factor into a 5x minus 3. And then a 3x plus 1. And that makes a solution here of positive 3/5. And that makes a solution here of negative 1/3. And remember, that's the opposites of these reduced fractions. Okay? Feel free to give this one a shot. Pause if you want. Right? Gotta put this in order first. Multiply 10 and negative 6. Find factors of negative 60 to make 11. Let's see, 15 and negative 4 will do that. Divide by 10. That reduces. 3 over 2. That reduces to negative 2/5. And so this is going to factor into 2x plus 3, 5x minus 2, which means one solution is going to be a negative 3 over 2, and another solution is going to be positive 2/5. Alright, so factoring, no big deal, we've seen that before. And the square root method we've partially seen. I like both of these methods, they're pretty efficient. It's the other two that take a little more work, and I would say the next method I'm going to show you, I like it, and the more you use it, I think the more you might like it as well. But the next method, if you don't like it after I show it to you, there will be sort of a way out of it. But why do we need another method in the first place? Well, let's look at number 8 here. If I wanted to solve this, we've established that we can use the square root method when this term is missing. So I know that I can't use the square root method here. So then that leaves us factoring. But are there factors of 1 that make 6? Well, no. So if we can't use the square root method and it's not factorable, that means we need another way to solve, right? Every quadratic equation is going to have solutions. It could be the 2 real, the 1 real, or the 2 imaginary, but it will have solutions, okay? No matter what. So we have to be able to find the solutions, and right now the other 2 methods aren't going to work. So I'm going to show you one called completing the square. If you've seen it before, heard of it before, basically what it does is it takes something like this that isn't factorable, and it makes it factorable by adding something to each side of the equation. And that's a legal move, right? As long as I keep the equation balanced, if I add to both sides, I'm not changing the equation. So, completing the square is, what does it mean to complete the square? It means to take a quadratic function, which we'll look at later, or equation that isn't factorable, and make it factorable. Okay, and it's helpful for solving quadratics. That's what we're going to use it for here. And it's also helpful for graphing quadratic functions, which we're going to do a little later. So it's helpful for this completing the square process for solving and for graphing. Okay, but for today we're going to use it for solving. So remember the standard form. Standard form is ax squared plus bx plus c equal to 0. Well, here this, like in number 8, this one is an issue. It's part of the reason why this thing isn't factorable. So what we're going to do is we're going to move the constant to the other side of the equation. So to use this process, oh, I skipped a step. And to move this, use this process, we want the equation to be equal to the constant. So we want to move the constant. Move the constant so that you have the ax squared, the bx, and then the equal c. Now, a stipulation of this process is that a has to equal 1, and it's really nice too if b is even, and you'll see why in a minute, but a absolutely has to equal 1 if you're using this process. If it's not 1, I'll show you how to make it 1, but a has to be 1, okay? So we want our equation to be equal to our constant. So for number 8, for instance, x squared plus 6x going to stay where it is. And I'm just going to take the positive one that's here and I'm going to move it to the other side by subtracting it over. So I got a negative 1 here. Now the goal is to add something to this side of the equation to make it factorable. And whatever I add to one side, I have to also add to the other side. So I'm going to put these little plus signs and these blanks in there to make sure I add to both sides. And what I add to both sides I find using a pretty easy formula. It says to take 1/2 of b and square it. Square the result. So in this case, b is 6. If I take half of 6, I get 3, and then I square that result to get 9. So I take half of b and then I square. So half of 6 is 3, 3 squared is 9, which means I need to add 9 to both sides of the equation. That's a legal move, okay? And now what happens is you're going to be able to factor on the left, and then you're going to be able to simplify on the right. And so let me show you here. If we factor on the left, well, what are the factors of 9 that make 6? Well, factors of 9 that make 6 are going to be 3 and 3, right? 3 and 3. And it's got to be the same number twice, and I'm going to show you why. If this factors into x plus 3 and x plus 3, then I could really write it as x plus 3 squared, okay? On the other side, the negative 1 and 9 go together to make 8, so now this is equal to 8. And now this should look familiar. What are we doing at this point? Well, now we can solve using our square root method. I can take the square root of both sides, and that leaves me x plus 3 equal to a plus or minus every time I square root. I'm going to break down the radical 8. 2 goes in 4 times, which means a 2 can come out and a 2 stays in. And then I gotta subtract the 3 over. So now I'm looking at my solutions, which are negative 3 plus or minus 2 radical 2. Ugly, okay, but there it is. We call it completing the square. Take something that isn't factorable and makes it factorable. And we need for the leading coefficient to be 1. And it's really nice if b is even, right? If this b that we take half of is even, it's nice. If it's an odd number, it's not so nice. It still works, but that's where I would opt for the fourth way that I'll show you in just a few minutes, okay? Let's try this again. So I want the equation to be equal to the constant. So the first thing I'm going to do is take the positive 6 here and I'm going to move it over, make it a negative 6 on this side. Now I got to find this magic number that I'm going to add to both sides to make this side factorable. So I take half of b. b in this case is negative 2. I take half of negative 2, which is negative 1, and then I square that. And what's negative 1 squared? It's positive 1. So positive 1 here and positive 1 here. And now this is factorable. What are the factors of positive 1 that make negative 2? Well, it's going to be negative 1 and negative 1. And that's going to end up being this number we get in this middle process every single time. So it was negative 1 here. Notice over here it was 3, and that's hiding here in the middle. So if my factors are negative 1, negative 1, then this is going to factor into x minus 1, or x minus 1 squared. and then this side over here, negative 6 and 1, makes a negative 5. And now I can square root both sides. So square root both sides, x minus 1 comes down, plus or minus. The only thing I can do here is take out the I, the negative is an I, and the 5 is stuck in the radical. And then I'm going to add the 1 to both sides. That's gone, and now x is by itself. So 1 plus or minus I radical 5, my two complex solutions. Okay, try this one more time. If you want to give it a shot, again, feel free to pause. So I'm going to make this x squared plus 8x. I'm going to move the positive 10 over here and make it a negative 10. What am I adding to both sides? Well, I have to take half of b, which is 8, that makes 4, square that, and that gives me 16. So I'm adding 16 here, adding 16 here. And factors of 16 that make 8 are going to be 4 and 4. So this is going to factor into an x plus 4 and an x plus 4. On the other side, 16 and negative 10 makes a negative 6, positive 6, just kidding. Now I can square root both sides. So now I have x minus 4 equal to plus or minus. Radical 6 doesn't simplify. Good, one less thing to worry about. Let's add the 4 over and call it a solution set, right? So this is a positive 4 plus or minus radical 6 that can't be combined, so that they are two real irrational solutions, okay? Now these are, in my opinion, the best case scenario for this process of completing the square, where a is 1 like it needs to be and b is even, so that when we take half of it, we get a nice number. Now here, notice that a isn't 1. If a isn't 1, we need to make it 1. So if where I need a 1, we got a 4, all we need to do to make it a 1 is divide that 4 out. Now we have to make sure we're dividing both sides of the equation, right? This whole side gets divided by 4, so does this side, that way we're keeping the balance. So we have 1 in front of the x squared, minus 2 in front of the x, and then 5/4, not so pretty. The other side here, 0 divided by 4 is still going to be 0. So we can still work this process. This is not going to be pretty, and this is where I think the fourth method would probably be preferable to this, but I'm going to show you just so you can work through it. We're going to take x squared minus 2x, we're going to move the 5/4 to the other side, and we're going to figure out what we got to add to make this thing work. So I'm going to add something. It's going to be half of negative 2, which is negative 1 squared, which is positive 1. And we had this scenario a few minutes ago, right? So adding 1 over, we said before, factors of 1 that make negative 2 are negative 1, negative 1. So this becomes x minus 1 squared. Over here, this you can put in your calculator, but we have negative 5/4, and we're adding 1, which is 4/4. So we're going to get a negative 1/4 as a result. So a negative 1/4 happening here, and feel free to put that in your calculator. Now we can square root both sides. So we have x minus 1 equal to, this is going to be plus or minus, we can square root each of these numbers, right? The square root of 1 is 1, and the square root of 4 is 2. So this is going to be 1 over 2, and because it's negative, it's imaginary. And then we can add 1, and there it is. We have x equal to 1 plus or minus 1/2 I. Okay, definitely not pretty. Now I like this process of completing the square, but to be honest, I probably personally wouldn't use it as soon as there's a fraction in there. So if you have to make a 1 by dividing and it creates fractions, I might not do it. And if b isn't even, when I go to take half of it and it makes a fraction, I probably would not use this process. Now, if it's something you like, it will come in handy later. You can absolutely use it. But if you don't like this process, there is another way. There's actually a quadratic formula. You've probably seen this before. This quadratic formula can be used to solve any quadratic. It can be used to solve any quadratic as long as it's in standard form. So if it's all in order and equal to 0, you can pick out your a, b, and c and plug into a, b, and c in this formula. Now, the formula, not the easiest to simplify sometimes, which is why I use it as a last resort. So I will look for square root method first, because that's the easiest method. And then if the x term is in there and I know I can't square root, I will try to factor. Now, if the square root and factoring don't work, if it's nice for completing the square, I would use that. If it's not, or you just don't like completing the square, then quadratic formula is your guy. Okay, it's your option. So a, again, that's going to be the coefficient of x squared. B is your coefficient of x. C is your constant. You plug those in. Make sure you're using parentheses when you plug things in. Especially here, we want to use the parentheses with that double negative. Okay. And use your calculator. You can do it in your head, but I would, once you get everything plugged in, it's actually half the battle. What we want to do is figure out one number underneath this radical and try to simplify from there. So you're going to use your calculator, hopefully. You can do it in your head, but use your calculator so you don't make mistakes, to get one number, under the radical. And then simplify the radical if you can. Right? And if the radical can or can't be simplified, once that's looked at, the very, very last thing you're going to try to do is reduce the fraction. So you're not going to try to do any reducing of the fraction until the very end. And you're only going to be able to do that if all three parts of the fraction have something in common. I'm going to show you what I mean in a second here. So let me go to my scratch work. When you use the quadratic formula, let's say you end up with something like 1 plus or minus, and you get like a radical 7 here and then a 3. There's 1, 2, 3 parts of this fraction, and the one that's here, the one that's here, and the 3 that's there, they have nothing in common, which means this would be done. You can't simplify that answer any further. But let's say you broke down a radical and you had like, not a 1 again. Let's say we had like 2 here, plus or minus 4 in front of a radical 3, and let's say you had a 6 here. Well, now the 2 and the 4 and the 6 all have something in common, so those could be reduced out. Since this are all divisible by 2, you would divide by 2. So then you'd have 1 plus or minus 2 radical 3 all over 3, and that would be your simplified answer. Now be really careful. If you had like a 2 plus or minus and then a radical 3 over 6 like this, you can't reduce just the 2 and the 6. You can only reduce if all three parts have something in common. Well, now the 1 isn't reducible with the 2 and the 6, so you're stuck here. Okay, so only reduce if all three of the parts have something in common. Okay, so you should also be able to approximate. You should be able to put this in your calculator and get a decimal. Approximate, and that will be helpful when we get to word problems, and we'll get to those later. But you should be able to approximate. Let me show you again. So if you had something like this. This is saying that 1 plus radical 7 over 3 is an answer, and it's saying that 1 minus radical 7 over 3 is another answer. You should be able to put this in your calculator and get a decimal. You should be able to put this in your calculator and get a second decimal. So you should be able to approximate these answers if you needed to. Okay? All right, let's try this out. To me, number 11 is the perfect candidate for this quadratic formula. It's not factorable and can't use the square root method. And if I wanted to complete the square, I would have to divide everything by 2, which is going to create fraction here, and I just don't want to deal. So this is exactly where I would use the quadratic formula. So A is 2, B is 3, and C is negative 8. So x is going to equal, we have a negative and then b, plus or minus square root of b squared minus 4 times a times c. That all gets divided by 2 times a. And so now let's clean this up. So a negative times the 3 is a negative 3. Plus or minus, under the square root, let's get one number there. So we have, I'm not going to put the square root in the calculator, just the part underneath, the radicand. So 3 squared minus 4, parentheses 2, oops, how did I not get the 2 in there? And then negative 8. And I could probably do some of that work in my head, I just don't want to risk making any mistakes. So it's 73 by a calculator. And then on the bottom, 2 times 2 makes a 4. Now 73 is a prime number, which is good. That means we cannot simplify the radical. And then because the 1 that's here, the 3 and the 4 have nothing in common, this is as far as we go. So these would be our 2 exact solutions here. Now again, this is something you should be able to approximate with the calculator. So just so you can see 1. If we had a negative, let me make a fraction first, a negative 3 plus a radical 73 on the top and a 4 on the bottom. Then we're looking at 1.386 as a solution. And if we change this to a minus, we're looking at negative 2.886 as a second solution, okay? So these are the approximate answers. Those aren't really necessary or useful unless you're looking at a word problem. More for word problems. If it's not a word problem, use the exact answers, but you should be able to approximate. Okay? All right, let's try this again. Now, looking at number 12, not factorable, can't use a square root. This is one where I would use complete the square because a is 1 and b is even, and I like the process of completing the square. But I'm going to show you here, if you don't like completing the square, that the quadratic formula is a perfectly viable option. So a is 1, b is negative 6, and c is 3. So x is going to equal a negative b plus or minus b squared minus 4 times a times c, all divided by 2 times a. Okay, so x is going to equal a negative negative makes that a positive 6 plus or minus. I'm going to get one number under the square root, and I can't hold it there. So I've got a negative 6, and if I don't put the parentheses there, when I do negative 6 in the calculator without put the parentheses, it's going to give me a negative, which I don't want. Let me just show you what I'm saying here. Negative 6 squared without the parentheses, the calculator is going to miscalculate. Okay, I want to make sure we're getting a positive 36 there. Minus 4, parentheses 1, parentheses 3. So 24 underneath the radical. So this, oops, sorry, this becomes a square root of 24, and then we're dividing by 2 here. Now remember, before we try to reduce, we want to make sure our radical is simplified. We didn't have that issue here because we couldn't break down the 73, but 24 breaks down. So if I break down 24, that's 2 and 12, 2 and 6, and 2 and 3, so a 2 is going to come out. So what we're looking at is 6 plus or minus. Instead of radical 24, this becomes 2 radical 6. And then we still have a 2 on the bottom. Now this fraction is reducible because the 6 and the 2 and the 2 can all be divided by 2. So that's going to make our final exact answers. If I divide by 2, we're going to end up with 3 plus or minus 1 radical 6 over 2. And those would be our 2 exact answers. 3 plus radical 6 over 2, 3 minus radical 6 over 2. Okay? All right. Feel free at any point to pause and try. We want to make sure that this is in order and equal to 0. So here a is 4, b is 2, c is 1, positive 1. So x is going to equal negative b plus or minus square root of b squared minus 4 times a times c, and that is all divided by 2 times a. So x is going to equal negative 2 plus or minus the square root of, let me not screw this up, 2 squared minus 4 times 1, which is a negative 12. Make this a little big here. Negative 12, and that's all divided by 8. Again, negative 12 is a radical we can simplify. So if I go to simplify radical negative 12, 2 and 6 and 2 and 3 means that 2 is going to come out and the negative is going to come out. So we're looking at x equal to negative 2 plus or minus, this becomes 2i, and radical 3 is left. And this is all being divided by 8. And now the 2 and 2 and 8 have a 2 in common. So I'm going to reduce by dividing by 2, which makes my final answers x equal to negative 1 plus or minus 1I radical 3 all divided by 4. Not pretty, but those are my imaginary, complex, actually, solutions. Okay? Now again, feel free to pause on this one and try it out. But I'm going to subtract the 5x over and then add the 4. Now, hopefully you're noticing something about this one in particular. Again, you want to look through your options first. If it's factorable, factoring is going to work much faster than this process, but and this one is factorable, but I want to show you what happens. So if I was looking at this problem, I would factor this. Factors of 4 that make -5 would be -4 and -1. And so right away I see my solutions are 4 and +1. Okay, but maybe you don't like factoring and you just have always struggled with that. The quadratic formula works for anything that's in standard form. So if you don't like factoring to solve, you can use this process. Use the formula. It solves any quadratic. What you would be plugging in here is 1 for A, -5 for B, and 4 for C. And what's going to happen is it's just going to simplify a little bit more nicely than the others, and I'll show you. So here x would equal a -b plus or minus the square root of b squared minus 4 times a times c, and that's all divided by 2 times a. So we have a +5 plus or minus, under the radical should be a perfect square. So a -5 squared, and a squared, and then it was minus 4 times 1 times 4, and there it is, 9. And I knew it was going to be a perfect square because I knew these answers were going to have to work out to be nice, rational answers, so I knew I was going to have to be able to take that square root. So if you find yourself working through the quadratic formula and you end up with a perfect square underneath the radical, it means you could have solved by factoring, okay? But let's make sure you can handle the simplifying here. So this becomes 5 plus or minus, the square root of 9 is now 3, and we're not going to stop here because over here I can't combine 2 and 2i, or here I can't combine 3 and radical 6, but I can combine these things, right? This is saying that 5 plus 3 over 2 is an answer, and 5 minus 3 over 2 is an answer. Well, 5 plus 3 is 8, and 8 divided by 2 is 4. 5 minus 3 is 2, and 2 divided by 2 is 1. There they are, your two solutions. Now, in my opinion, much easier to solve by factoring, but again, this formula works for any quadratic in standard form. So if you find yourself stuck, use the formula. As long as you know how to simplify, you're going to get to those answers, okay? It's a lot for one day. I apologize, but this crazy suspension has caused me to have to cram some things together. So do your best. Fortunately, only 2 of these are new, and if you don't like completing the square, you can absolutely use quadratic formula in its place.